Today we're going to continue working with percent problems, but we're going to focus on applications of percent. I'll be using the proportion method that we learned last time, where you take the percent over 100 equals the part over the total to solve each of these problems. But if you prefer the equation method, feel free to do the problems that way. So let's just start by doing some examples. On a 120 question test, a student answered 96 correct. What percent of the problems did the student do correctly? So I'm solving for the percent. So that means the x goes over the 100. Now I just have to figure out which number is the total and which is the part. Well, the total number of questions is 120, and the part that the student got right is 96. Now I can solve this proportion by cross-multiplying. So 120x equals 9600, and to finish I'll divide by 120. So x is 960 divided by 12, and 12 times 8 is 96. So 960 divided by 12 would be 80, and my answer is a percent. 80% of the problems were done correctly. Example 2. If 25% of students get A's in a certain class and 300 took the class, how many students will get A's? Well, this time I know the percent, that goes over 100. And then am I solving for the total or the part? Well, only part of the class gets A's, so the x goes on the top. Total number of students is 300. So now I can set those cross products equal. 100x equals 7,500. To finish, I'm going to divide both sides by 100. And my answer is 75. 75 students will get A's in this class. Example 3, in a shipment of airline parts, 3% are known to be defective. Okay, we know the percent, that always goes over 100. If 15 parts are defective, how many parts were in the shipment? So this time we're actually solving for the total number of parts in the shipment. That means the x goes on the bottom. The 15 is part of the total, that goes on the top. And of course, once you have that proportion written, you can set those cross products equal to each other to solve. So 3x equals 1500, divide by 3, and x equals 500 parts. Now, some of the applications you see might involve a percent increase or decrease. One example of that would be sales tax. For example, in example 1, it says, suppose the sales tax in Mississippi is 6% of the purchase price. If a fridge costs $5.50, how much sales tax is there? And then we also want to know, well, what is the total price of this fridge? So in a percent increase or decrease problem, there's often two steps to the problem. The first thing we have to do is figure out how much sales tax is there. And the amount of sales tax is going to be a part of the total. So setting up my proportion, 6%, 6 over 100. The sales tax is the part, and the total cost, or the purchase price, is $5.50. So I can set the cross products equal to each other. And I get 100x equals 3,300. Divide both sides by 100, and x is 33. Now that $33 is the tax that we're going to have to pay on this fridge. And so then the second part of the problem, what is the actual total price here? We have to take the purchase price, the ticket price, $5.50, plus the tax. So in the end, that item is going to cost $583. Example 2, if a person earns $22,000 a year and gets a 5% increase in salary, what is the new salary? So again, this is a two-step problem. The first thing I have to do is find the increase in salary, and then I can find the new salary. So we've got 5% over 100. And when you're finding a percent increase, you're finding a part of the total. The raise is a part or a fraction of that overall salary of $2,200. So I set the cross products equal, and I get 100x equals 110,000. Divide by 100, and x equals 1,100. Now this is a two-step problem. I'm not actually done with the problem. The 1,100 is the amount of the raise. To get the new salary, I have to take her old salary, 22,000, and add that raise. And so the new salary would be 23,100. Now, if you want to find a percent increase or decrease, if you want to actually find that percentage, you still set up your proportion, but now your part is actually going to be the change in value, and the total is always going to be the original amount. So let's see how that works with an example. Shoes that cost $25 are on sale for $21. What is the percent change? So the change in price is actually $4. I'm trying to find the percent, so the x goes over 100. The change is $4. And for the total, you always want to do the starting amount. In this case, that's $25. So I set my cross products equal, divide by 25 to solve, and I get x equals 16. So these shoes were on sale for 16% off. The same is true with a percent increase. In my last problem, we had percent decrease. If I want to find a percent increase, first thing I have to do is find the change. So the population of a country was 4 million, now it's 5 million. So the change in population is 1 million. I'm solving for percent, so x goes over the 100. The change is always the part, and the total is that starting value, the 4 million. So I can set the cross products equal to each other. 4x is 100, divide by 4, and I get x equal 25. So this population went up by 25%. Now the last thing I want to show you is simple interest. This is also an application of percent. There is a formula for simple interest. This is a formula that you actually don't need to memorize. The formula is I equals PRT. I stands for interest, P stands for principal or present value, R is the interest rate, and T is time, always measured in years. So let's see how this formula works with an example. Allison borrows $8,000 from a bank with 12% interest. How much interest does she owe after 3 years? So I'm solving for I, so I'm going to have to plug in something in for P, for R, and for T. P is the amount she borrows, the $8,000. The interest rate is 12%, and when we use equations or formulas, we have to change our percentages into decimals. So 12% would be 0.12. The only time we don't have to change our percents to decimals is when we're doing those proportions. And then time is 3 years. So plugging in this into the formula, I get I equals 8,000 times 0.12 times 3. Now I can multiply in any order I want, so I'm going to do the 8,000 times 3 first. That's 24,000. And then I'll finish by taking 24,000 times 0.12. And when I multiplied, I got 2,888. And when I multiplied, I got 2,880. Example 2, a student takes out a loan of $12,000 at 4% interest rate. How much will he owe after 3 months? So P is 12,000, R is 0.04. Now time, I had this written down on the previous page, time is always measured in years. And so we're going to have to convert that 3 months into years. And let's see, well, there's 12 months in 1 year. So 3 months would be 3/12 or 1/4 of a year. If you want to change months into years, you can always just divide by 12. So then I plug those numbers into my formula. I can multiply in any order I want. I'm going to do the 12,000 times 1/4 first. Multiply straight across, that's 12,000 over 4, or 3,000. And then to finish, I have to take that answer 3,000 and multiply that by 0.04. And I end up getting $120. All right, last example. Jeffrey invests $1,200 into an account that pays simple interest. After 6 months, he's earned $36 in interest. Okay, this problem's a little bit different because now they're asking us to find the interest rate. They're asking us to solve for R. So I'm going to have to plug numbers in for I, P, and T. So let's see, the interest earned, they said, was $36. The amount he invested, the P, is $1,200. And the time is 6 months. Time always has to be in years. So 6 months is 1/2 of a year. Plugging these things into my formula, I is 36, P is 1,200. I don't know what R is, and T is 1/2. So I'm using the exact same formula, it's just the problem feels a little bit different because I don't plug anything in for R. I actually have to solve for R. So I'm going to start by multiplying. You can multiply in any order you want. So I'm going to multiply the 1,200 times 1/2. And 1,200 times 1/2 is the same as 1,200 divided by 2. That's 600. So 36 equals 600 R. To finish, we can divide both sides by 600. And let's see, to help me with the division, I'm going to reduce. Both of those numbers are divided by 6, or divisible by 6. So R is 6 over 100. I have to write this as a percentage. You might recognize, because we got lucky and the denominator is 100 in this case, the 6 is the percent. The answer is 6%. If you don't recognize that, you have to convert this into a decimal. Dividing by 100 always moves the decimal 2 places to the left. So R is 0.06, but then as a percentage, we actually move the decimal back to the right, so the interest rate must have been 6%. That's it for this lesson. As always, let me know if you have any questions.